Here's the problem with the multiplication rule. So we have a bag containing 3 red chips, 4 blue chips, and 5 black chips. 1 chip is drawn at a time. So what is the probability of drawing a red chip? So total chips, 3 plus 4 plus 5. So all of these, all of these will give me a total of 12. Okay, so we have 12 total. Okay, so what we want to do, we want to figure out the probability of getting a red chip. Since it doesn't say replacement or without replacement, I'm assuming that we're going to this will be the first red chip that we draw. So we have 3 total red chips out of 12. Okay, so this will be my probabilities since we have 3 red chips out of 12 total. Okay, for this one, what is the probability of drawing a green chip? Okay, well, all we're just looking at is, well, look at the green chips. Well, there's no green chips here. So since there's no green chips and it's not part of our sample space, this will just be 0. Okay. Just, it's not in our samples. We only have red chips, blue chips, and black chips. Okay. So now, suppose you drew a red chip first. If drawing with replacement, what is the probability that you draw a second red chip? So I drew a red chip first, and now I'm replacing it back. That's what this replacement means. So what is the probability that my second one will be red also? So second is red. Okay. If my first one was red, you can write this, or you can write given that first one was red. Well, the first one being red, well, that didn't really affect anything. So the probability of getting a second red chip is not going to really do anything. So it's just going to still be 3 out of 12. I didn't do anything with the first red chip. I just replaced it. So it's as if nothing has happened. Okay. So these were independent events. Okay. So suppose we drew a red chip first. If drawing without replacement, so now I got rid of this red chip. What is the probability of drawing a second red chip? So the probability of drawing a second red chip, if the first one was red, is now going to change because now I'm drawing without replacement. So I'm not replacing it back. So now I'm left with 11. And now how many red chips? Since I got rid of this red chip first, now I only have 2 left. So it's 2 out of 11. Okay. All right. So now what is the probability of drawing 2 blue chips in a row with replacement? So remember the key word here is in a row, and in a row just means multiplication. So we're taking into account both blue chips. So the probability of the first one being blue and the second one being blue. Okay, so the probability of the first one being blue, so let's go ahead and look back. How many blue chips did we have? We had 4 blue chips. So we started out with 4 blue chips, so that's going to be 4 out of 12. Okay, so that's what we started with. Now, since I'm replacing it back, I'm not doing anything with the blue chip, and we still have the same amount of blue chips, so this is also going to be 4 out of 12. It's going to give me 16 out of 144. And that is going to be my total answer. Okay, that is the probability of drawing 2 blue chips in a row with replacement. So what is the probability of drawing a red and then a black chip without replacement? So we have a particular order that we're looking at. So what we're looking at is the first one being red and followed by the second one being black. Okay, without replacement. So I'm not replacing it. So first I'm drawing a red chip. A red chip, there's 3 red chips out of the total 12. So you have 3 out of the total 12. Now with this red chip, I went ahead and got rid of it. So now I only have 11 left. So now we're looking for what is the probability of then selecting a black chip. So if we go back, we haven't done anything with the black chips. We still have 5. So this is going to be 5 out of 11. So 3 times 5 gives me 15. 12 times 11 gives me 132. Okay, so this will be the probability of selecting the first one being red and the second one being black. Okay. All right. Now, part G. What is the probability of drawing 2 red chips in one draw? Okay. So can I do 2 red chips in one particular draw? Well, no, because if you go back to the problem, it says we are drawing 1 chip at a time. So is it possible for me to get 2 red chips in one draw? Well, the answer is no. We are only drawing one at a time. Which basically means, one at a time. Which basically means that these 2 red chips in one draw is actually a disjoint event. Okay. Now, what is the probability of drawing a blue or a black chip? So the probability of getting a blue or getting a black chip. Well, remember, we have or, so we're going to have probability of getting a blue plus probability of getting a black minus the probability of getting a blue and black. Okay, so the probability of just getting a blue chip, okay, if we go back, is going to be 4 out of 12. The probability of getting a black chip is 5 out of 12. Okay, minus the probability of getting a blue and a black. Well, I cannot get a blue and a black in one draw, so this is going to be 0. Okay, so this is just going to be equal to 9 out of 12. So remember, this is going to be 0 because we cannot get 2 of them in one draw. This is assuming that we're getting it in one draw. Okay, all right, so hopefully these questions helped a little bit and clarified a couple problems. Okay.